Welcome to Brain Vision.
All right, here's another great problem to do on a graphing calculator. And so we're going to go into the Statistics menu and go into Edit. And then we're going to type our numbers into List 1 and List 2, where List 1 stands for the distance, the average distance of the planet from the Sun, and List 2 stands for the period, the time of revolution around the Sun. Okay, once we have those numbers typed in, we want to find the power model. So we go into the Stat menu, and then we go over to Calculate, and we go down until we find Power. It's a little ways down in the list. There we go, Power Regression. We press Enter, and we are using List 1 and List 2. We don't need to worry about frequency list. We don't need to store the equation anywhere. We can just calculate. So here's our power regression model. It's approximately y equals 1 times x to the 1.5 power. Okay, let's move on to Part B. So Part B talks about Kepler's third law of planetary motion, saying that the square of the period of the revolution of a planet is proportional to the cube of its mean distance from the Sun. Well, that can be translated into this equation. The square of the period would be t squared, is proportional to means we have some constant of proportionality k, and then the cube of the mean distance would be the distance cubed. We want to know if that equation is similar to this equation that we got. Well, in the equation we got from the calculator, our t is actually y, and it's not squared, it's just t, just y. So what we're going to do is square root both sides of the equation to get t equals instead of t squared equals. And when we do that, when we square root both sides of the equation, we end up with some other k. This k may not be the same as the other k because we've square rooted it, but it's still just some constant k times d to the 3/2 power. Now the 3/2 power is equivalent to the 1.5 power. So I would say that the model we found is consistent with Kepler's third law.